Hey everyone, welcome back to the channel. Today we're going to be starting on the math section of the GED with the first topic within math, basic math. If you haven't already checked out my other video detailing the best ways to study and how to use all this information, go ahead and check that out first, then come right back on here. These are the main topics we'll be covering today, and if you want to find out more detailed instruction, I'll be providing references to the specific Khan Academy videos, and you'll find those links in the description. So we'll start off with fractions and decimals in order. Say that we're given four numbers, 0.3, 1/2, 1/3, and 0.8, and that we are asked to put these in order. So for this, you'll need to know how to convert fractions and decimals. And if you're not sure exactly how to do this, the Khan Academy video that you should check out is named Converting Fractions to Decimals, and we'll link to that in the description. But to make things quick, the easiest way here is to convert everything into decimals. So we'll still have 0.3, 1/2 is 0.5, 1/3 is 0.33, and we'll move over 0.8. And if we look at these, we can see that our smallest number is 0.3, because that would be the same as 0.30, followed by 0.33, 0.5, and lastly 0.8. So a question for one of these could look something like this, and it asks, between which pair of fractions should 0.35 be placed? And we see we have a number of fractions, less than 1 for answers here. So the easiest way, we will start to convert each of these into decimals and see where 0.35 should be placed. So starting off up here with between 1/4 and 1/3, and if we convert that, that would be 0.25 and 0.33, and we see that it is not between those two, but if we move on, we have 0.33 as 1/3 and 1/2 at 0.5. And as we can look ahead and see that they only get larger at this point, so we know that B is going to be the answer. Number 2, multiples and factors. So multiples are the numbers that you get when you multiply a certain given number by a set of whole numbers. So for instance, the multiples of 5 would be starting with the multiplication of 1, and then by 2, by 3, by 4, and so on and so forth. So if we take that through, we have 5, 10, 15, 20, and so on. Factors, on the other hand, are the whole numbers that you can multiply by to get a certain number. So for instance, for the factors of 6, we will find every whole number that you can multiply by to get 6. So for instance, let's look. 1 times 6 is going to equal 6. What else? 2 times 3 is going to equal 6. And so the factors of 6 are going to be 1, 2, 3, and 6. Now you'll also run across prime numbers such as 5, where the only factors are the number and itself. There's no other whole numbers we can multiply by in order to get 5 other than 1 and itself. So an example problem here could be that Jack and Jill are opening lemonade stands and they want to make at least $20 to buy movie tickets. So Jack sells his lemonades for $4 and Jill sells hers for $3. They each need to make at least $20, but they want to earn the same amount. What amount do they need to earn? So we'll need to figure out the multiples of 4 and 3, see where they match up. In other words, the least common multiple. And we'll also need to pay attention to make sure that they're earning at least $20. So the multiples of 4 are going to be, so the multiples of 4 are going to be 4, 8, 12, 16, and 20, 24, 28, and so on. The multiples of 3 are going to be 3, 6, 9, 12, and if we were just looking for the least common multiple of 4 and 3, we'll see that 12 would be that case. But we are looking to make at least $20, so we need to continue 15, 18, 21, and 24. There it is. So they would need to each earn $24. A problem could also ask how many drinks that Jack needs to sell or how many drinks Jill needs to sell. So you take that extra step of then dividing or seeing 1, 2, 3, 4, 5, 6, 7, 8 drinks for Jill and similarly for Jack. Number 3, simplify exponents. I'm going to put up on the screen the rules for dealing with exponents, but we're just going to be focusing on the first 4 of those rules. And if you need more information on this, the Khan Academy video we recommend is called Simplifying with Exponent Properties. A question that will also expand on some of these rules is this one. You would be asked to simplify the expression 5 squared times 9 to the 5th and all of that squared times 5 to the power of 4. So we can go ahead and move this squared exponent through this expression on this side, and that would end up looking like 5. So we do 2 times 2 when the multiple, we do 2 times 2 when the exponent is being squared. So we can multiply through these. So 2 times 2 is going to be 4 times 9 to the 5 times 2, 9 to the 10th. And we'll go ahead and just move this down. And then these parentheses can be dropped. So we can combine these two because they have the same leading number of 5. So it would be 5 to the 4 plus 4, then still 9 to the 10th. So that would be 5 to the power of 8 times then 9 to the power of 10. Number 4, distance between numbers on a line. So I don't think we need to refer to another video for this one. It's a pretty simple concept. Basically, if you plot out a series of numbers on a line, and we're going to go ahead and put 0 in the middle and go forward on one side. Simple, we just have numbers literally on a line looking kind of like a ruler almost, but also going into the negatives. And you'll be asked the distance between 2 points on this line. And that distance is going to be an absolute distance, meaning that it's going to be a positive number. A question could ask what is the distance between -3 and 4 on a number line? So we would just look up here and count from -3 to 4. 1, 2, 3, 4, 5, 6, 7 will be our distance. And yes, if you've already caught on, you can just subtract and take the absolute value of these numbers. So you could do -3 minus 4 and end up with -7, take the value positive at 7, or you could even do the reverse way, 4 minus -3, which is going to be +7. Number 5, whole numbers, fractions, and decimal problems. These problems you're going to need to remember your PEMDAS, which is the order of operations, parentheses, exponents, multiplication, division, addition, and subtraction. If you need to review any of these order of operations steps, go ahead and take a look at the Khan Academy video titled Intro to Order of Operations. So a question is going to test your knowledge of that order of operations and ask you to simplify an expression. So here we have 8 minus 3 times, in parentheses, 2 plus 4 plus 15 divided by 3. And if we start to work through first with parentheses, we will have 8 minus 3 times 6 plus 15 divided by 3. Then we'll work with our multiplication here and division here. So that would be 8 minus 6, 12, 18 plus 15 divided by 3 is 5. And then we'll just go through 8 minus 18 will be -10 plus 5. So we round out with -5. Number 6, squares, square roots, cubes, cube roots. So as a quick reminder of what these are referring to, 6 squared would be the same as 6 times 6, which is going to be 36. and then respectively the square root of 36 is going to be what multiplied by itself equals 36. And so we just working backwards here. So the square root of 36 is going to be 6. Now the cube is similar except to the power of 3, meaning that we'll do 6 times 6 times 6. So in other words, 36 times 6, which is 216? Yeah, 216. And then following the same pattern, a cubed root, which will have a little 3 out there because of that. The cubed root of 216 is going to be what multiplied by itself 3 times equals 216. And we obviously know here it's going to be 6. If you need some more practice on these types of problems, the Khan Academy video I would recommend is adding and simplifying radicals. I'll also note that there's quite a few different videos detailing similar subjects for the Khan Academy videos. So go ahead and look around a little bit on their page to see what else you can find if you're still struggling after the first video. An example problem could be simplify the cubed root of 13 plus 5 times the cubed root of 13 minus the square root of 13. And we can combine these two terms here since they're both the cubed root of 13. This would have a 1 in front of it since there's nothing there. So that would end up being 6 times the cubed root of 13. 13 is a prime number, so we're not going to reduce that. And then since this is a square root and not a cubed root, we cannot combine those terms. And so this is simply going to stay the same as minus the square root of 13. Number 7, undefined expressions. So for the GED, you're going to need to know two types of undefined expressions. And by an undefined expression, we basically mean a number that doesn't exist. So the first type here is going to be the divide by 0. So let's say that you have 2 apples and you want to divide them between 0 of your friends, including yourself, not even divided by yourself. Well, to say 2 apples divided by no one doesn't really make sense. So we call that an undefined expression anytime we have a divide by 0. The second type of undefined expression you'll need to know is the root of a negative number. So an example here would be the square root of negative 9, because you cannot, if you try multiplying two negative numbers together, you're ending up with a positive. If you're doing two positive, you end up with a positive, and you can't do a mix to get that square root number. So we would also call this a undefined expression when you have the root of a negative number. For example, a question could give you an expression of 2 divided by x plus 5, and it asks for which value of x is the expression undefined. And we're given a set of answers here. So we know that x, for one, cannot be the root of a negative number, because if that's anywhere in that expression, it'll make it undefined. And we're looking through the answers here, and you may think, oh, here's a negative square root. But you can see the negative is outside of the square root, which would not make it an undefined expression. It's only when it is inside of the square root or other root that you'll have that undefined problem. Anytime that the denominator of this division equals 0, we're going to have an undefined expression. So if we put in 0 there, it's just going to be 2 over 5. But if we put in negative 5, that'll make it divide by 0, giving us an undefined expression. So the answer here is B, negative 5. Number 8, unit rates. This is referring to anything like miles per hour, or possibly the price per dozen eggs, which has gone up recently. Other examples could be profit per sale, if we're talking about business. Anything like that where we have a set unit divided by or over the time span of another unit, or over the duration of another unit. For example, a question may ask, a farmer gets paid $55,000 for his corn. He has 4 fields and each field is 11 acres. How much is the farmer paid per acre? So for this, we would simply start to work through first seeing how much he gets paid per field. So we would take 55,000, divide that between 4 fields, and we end up with 13,750. Yes. And so that would be $13,750 per field, but the question is asking how much is he paid per acre. So we continue down this road with then 13,750 divided by 11 acres, and I'll need to bust out the calculator for this one. So we end up with $1,250 earned on the corn per acre. Number 9, objects at scale. So you'll have to use scale factors to convert dimensions between scale drawings and actual objects. The Khan Academy video for this one's called Scale Drawings, and we'll jump right into an example. Okay, so let's say a question gives you the dimensions of a basketball court as 50 by 94, and you're told that a miniature court has the width of 15 feet. What would be the length if the scale matches? So to do this, we will see that the 50-foot portion is going to be matched up with the 15-foot portion. We have the 94-foot portion matching up with the answer we're looking for. So 15 goes into 50 by 3.33 to get to 50. So what multiplied by 3.33 would equal 94? So we'll do 94 divided by 3.33, which we end up with 28.23. And if we think about it, we can tell that, yeah, that's probably the correct answer because it's almost double 15, which just looking at this scale, we know that the length is almost double the width, but not quite. So it'd have to be under 30, but not by much. So we have our answer at 28.23. Number 10, multi-step problems using rations, proportions, and percents. So this will include problems such as simple interest, percent increases or decreases. It's pretty tough to talk and write correctly at the same time. I'm finding that out. Another types are going to be gratuities or tips. I know I didn't spell that right. Forgive me, we're talking about math, not language arts in this one. And then finally, commissions. Meaning like, a used car salesman earns a percentage of the car that he sells. So some Khan Academy videos that you should take a look at. Anything with ratio and proportion or ratios, rates, and percentages in the title, we've got 2 of them we'll link to in the description. So I'm going to use a question that I really like off the GED website, but I've changed the numbers up some in case you run across it yourself so you can try that problem yourself. For this, I really like this problem because you need to read carefully and follow the order that they're describing. So you start off with 1074, and you may be tempted to take 7% of 1074 and 15% of 1074, add all that together and get the answer. And I'm sure that one of those multiple choice answers is going to be that. But what you need to see is that you paid a 7% tax, then a 15% tip. And I'm not sure if I read this already, but the price of your meal before tax and tip was $10.74. You paid 7% tax, then a 15% tip. What was the final amount paid? So we'll go ahead and first we need to add on this tax. So that would look like $10.74 plus we need to do 7% of 1074. So we do 1074 times, and remember if we're working with percents, then we need to turn that into a decimal, so move the decimal spot 2 places, and we'll end up with, $11.49, well, $11.49 1.492. I'm going to leave an extra decimal there just to carry it through and then round off in the final spot. Another trick here I want you to know about, just to save you a split second, but you can also do 1074 times 1.07. That's going to give you the same answer, save you a little bit of time on the test. So now that we have the total amount with tax, then we need to add on the tip. So following this same method here, why not? So we'll have 11,492 times 1.15, sorry about that. And we end up with a total amount. We end up with the final answer here of $13.22. Hey everyone, welcome back to the channel. Today we're going to be going over the second official GED topic in math, geometry. If you haven't seen my other videos, you might consider checking those out first to know how to use that material. Otherwise, let's not waste any more time. Let's get right into it. But first I want to ask you, what is that thing? As a reminder, these are the topics we'll be going over today. You will be given formulas for most of these problems. If you are struggling with a certain topic, I will be providing references to Khan Academy videos that will give you a deeper dive into the individual topic. Those will be linked in the description. Number 1, side lengths of shapes given the area or perimeter. The shapes that they're referring to include triangles, rectangles, and polygons. Polygons is any shape that has straight edges and 3 or more sides. You may recall that perimeter is the length of the outside of a shape, while the area is the squared dimension of the interior of the shape. So for a rectangle, the area is 1/2 base times height, the base being the length of the side opposite the height. So we have the height here and the base here, and we'll do 1/2 base times height. The perimeter for a case like this will be adding up the edges a plus b plus c. Similarly, for a rectangle, the area is just the base times the height, and the perimeter is going to be all of the edges added up. So b plus the same length over there, b plus h, or 2b plus 2h. An example question is this. A triangle has an area of 20 square inches and a height of 8 inches. What is the length of the base? So looking at our formulas, we can see that the area is equal to 1/2 base times the height. We will plug in the numbers. We know 20 square inches for the area. Pull down that 1/2. The base is what we are looking for, and the height is 8 inches. So then we'll just follow through all of our regular math. We'll multiply each side by 2 to get rid of this, and then divide by 8 to get rid of that, and equal with a base of 5 inches. Number 2, area and perimeter of 2D shape. And the two-dimensional shapes they're referring to include polygons and composite shapes. Polygons, you may remember, are any shape that includes triangles, rectangles, and more sides. Composite shapes will be any shape that combines 2 elements together. This is an example of a composite shape. We can see that it's made up of multiple rectangles along with half of a circle. The question asks, a pool is designed as shown. Yellow caution tape will be placed around the edges during construction. If the tape comes in 8-foot rolls, how many rolls are needed? So we can see we're given some dimensions here, but not all of the dimensions, and we're not given the radius of that circle. So first we'll need to figure out what the remaining dimensions are, and then since the caution tape will be going around the edges, we're actually looking for the perimeter here. So just looking at the problem, we see that there's a 10-foot section here and a 5-foot section here. Now we're assuming that all of these lines are perfectly straight, so the diameter of the circle here will also be 5 foot, and we know that the diameter is half of the radius. We'll learn that in the next section. So this is actually going to be 2.5 for that radius, and the other missing dimension is right here. And we can see that we have 8-foot section minus 3 right there, so 5 is what must be remaining. If you have questions about how I did that, ask them in the comments. So moving on here, we'll go around and add up the perimeter. So 5 plus 5 is 10, plus 3 is 13, plus 10 is 23, plus 8 is 31, plus the perimeter of half the perimeter of that circle. Technically, when we're talking about the perimeter of a circle, we call that the circumference. We'll learn in the next section that the circumference is equal to, I'm just going to move these down to 2 pi r, but we only have half of that circle, so we're going to do 1/2 2 pi r. R is the radius. We know that to be 2.5. It's looking a little messy here, but we'll follow it through. Add on the 31 from the 13, 23 plus 8, 31, and that's going to give us the perimeter. We end up with 4.36, and since we can't just purchase a third of a roll, we're going to round that up to 5 rolls needed, and that would be the answer. Like the first section, you're going to need to be able to work both ways if they give you certain dimensions of a circle to calculate the area and circumference, or given the area or circumference to calculate the radius or diameter. The radius of a circle is the length from the center point of the circle to the edge, and the diameter is twice the radius, so the full length from edge to edge of a circle. Diameter is 2r, or we can see that the radius is equal to d divided by 2, 1/2 the diameter. The area of a circle, the interior portion squared here, we will be given that as pi r squared. You may remember that pi is equal to 3.14. Perimeter of a circle is what we call that the circumference, but essentially the same thing. And the circumference is going to be 2 pi r. 3 quick problems to run through. The first one, if you're given the radius or diameter and you're asked to find the area or circumference. So let's say you're given a radius of 3 inches, you're just going to plug in chug. Remember, the circumference is equal to 2 pi r, 3 inches. You'll just plug that into your calculator and find it to be 18.85 inches. And the area, again, we're just plugging and chugging here. So we got pi r squared. Remember that 3 squared is just 3 times 3, and we'll find that to be 28.27 inches squared. Given the area, find the radius. So if you're given the area of a circle to be 25 inches square, we're going to work backwards here. The area 25 inches squared equals pi r squared. And then we'll just follow through basic math here. So r squared is equal to 25 divided by pi, and then we'll take the square root of each. So we end up with r is equal to the square root of 25 divided by pi. Plug that into your calculator. The last one, given the circumference, find the diameter. So we have circumference of 12 inches, and we see 12 is equal to 2 pi r. So we'll go through, figure out that r is equal to 12 divided by 2 pi. Remember, it's asking for the diameter, and the diameter is twice the radius. So the diameter is equal to 2 times 12 divided by 2 pi. And all you got to do is plug that in. Don't get freaked out by all this extra stuff in there. Plug it into your calculator, you're good to go. Number 4, use the Pythagorean theorem to find the side lengths of a right triangle. So first off, what is a right triangle? A right triangle is one that has a corner with a dimension of 90 degrees, meaning that is, or an angle of 90 degrees, meaning that angle is 2 sides completely perpendicular or opposite, you may think, of each other. So that's when we're able to apply the Pythagorean theorem, which says that if you have 3 sides of that triangle, the 2 sides that are next to that 90-degree angle are going to equal the other side when we square each one of them. So you may remember a squared plus b squared equals c squared. You're going to be given certain dimensions and asked to find the other dimensions, but only of a right triangle. Just as a reminder, the other types of triangles, we have an obtuse triangle when one of the angles is greater than 90 degrees, and then we also have acute triangles, which are when all the angles are less than 90 degrees. Remember, Pythagorean theorem only applies to right triangles. An example problem could look like this. You're given a triangle with the following dimensions. They may have angled it here some to try to throw you off, but remember that you're looking for that 90-degree angle, which is right there, and you're asked to find the dimension n. So here we will bring this formula down and plug in the numbers, let's say that n squared plus 2 squared equals 3 squared. And we're using 3 there because it's the one that is opposite of the 90-degree angle. Then we'll come through and we know that that's going to be 9. We'd subtract 2 squared from each side, which is subtracting 4. N is equal to 5. That's the answer. Another sample problem that I accidentally wrote in blue this time, let's say that you're told that a new phone is coming out and it has the following dimensions of 5.7 inches by 3 inches. And we know that screen sizes are measured on the diagonal from corner to corner. The question asks you, what is the screen size of this new phone? Applying the theorem, we can assume that each of these are right triangles and that the dimensions are the same on each side. So we're looking for the length opposite the 90-degree angle. And so we'll have 3 squared plus 5.7 squared equals that screen size, let's call it s squared. And we'll follow through just like we did up here to simplify and find that s, the screen size, is equal to 6.4 inches. Number 5, volume and surface area of 3D shape. Volume refers to the amount of space an object holds. So if we're looking at this fancy rock here, the volume would be the amount of space inside of it. The surface area would be all of the outside added up together. You'll be provided with the formulas for finding the surface area and volume of these shapes. You'll just need to know to recognize which dimension gets plugged in where. So for instance, if you're given a cylinder and they tell you what the height and radius is, they may ask you to find the surface area or volume. And the surface area for a cylinder is going to be 2 pi r h. 2 pi r squared. The volume for a cylinder is going to be pi r squared h. And again, you'll be given the radius and the height dimensions, and you can simply plug in and calculate the surface area or volume for any of these shapes. Just try to be familiar with how to apply those formulas to the given shapes. Similarly, you may be given the volume of a sphere and asked to find the radius, so we're working in the opposite direction here. But again, you're just going to plug in the numbers where needed and follow through with that calculation to find the radius. Number 6, graphical data. For these problems, you'll be provided any of tables, graphs, or plots and asked to interpret that and provide an answer. The interpretation, it's not going to ask for anything real fancy, but it's going to be testing your knowledge of just being familiar with each one of these. I'm going to throw one up on the screen for each of them and give a quick explanation, but if you have a more detailed question, leave it in the comments. A table shows the raw data organized, usually the basis for other representations. A bar graph shows data using lines, usually with unordered data. A line graph is similar, but uses a line to connect the points, usually showing data that occur over time. A circle graph or pie chart shows how much each set is a percentage of the whole. Dot plots are basically bar graphs, except they have dots. Box plots show the range of sets of data. Histogram is a bar graph that basically could be a line graph, and scatter plots show all of the data points plotted often so you can see what kind of patterns emerge. Number 7, mean, median, mode, and range. When you're given a set of numbers like this, you may be asked to find the mean, median, mode, or range of that set of numbers. The mean, you may recall, is the average of that set of numbers. The median is the middlemost number. The mode is the most often occurring number. And the range is the largest number minus the smallest number. Let's use this data set to find each of these. So first I'm going to arrange this in order. So we have 1, 1, 1, 2, 4, 5, 6. Once I have that, the mean is going to be the average of all of the numbers, so I'll do 1 plus 1 plus 1 plus 2 plus 4 plus 5 plus 6, and then divide that by the total number, which there's 7 of them, and we will find out that just plug in those numbers, divide by 7, you'll have the average answer. The median is the middlemost number. We can see that here is going to be 2. The mode is the most often occurring number, which is 1. It occurs 3 times. And the range is going to be the biggest number minus the smallest number, so that would be 5. I didn't want to leave you in suspense, so the answer here, that average, turned out to be 2.9. You'll also need to find a missing value when given an average. So a question for that could look like this. After the test, Tom averaged the scores of his study group and found it to be 89%. The others in his study group scored 88, 79, and 91. What did Tom score? So we're going to have 4 people apparently in this study group with the scores of 88 plus 79 plus 91 plus Tom's score, and then we divide that by 4, and we know that turns out to be 89%. So we'll multiply each side by 4 and then subtract 88, 79, 91 to end up with Tom's score to be 98%. He did really well on this exam, probably because he's a nerd and he's coming after the exam and averaging scores. So yeah, good job, Tom. Number 8, counting techniques. You'll need to count how many different ways objects can be ordered, arranged, combined, things like that. I get asked a lot specifically about the GED sample problem that is given. So first, let's refer to that. I'm going to put it up on the screen, and it says, a restaurant serves custom-made omelets where guests select meat, cheese, vegetables to be added to the omelet. There are 6 vegetables available, and guests may select any 2 vegetables for their omelet. How many different combinations of 2 vegetables are available? So essentially, this problem is telling you that there's 6 vegetables. How many different combinations of 2 vegetables are possible? There is a formula that you can use for this, but the easiest way to depict this problem will be visually. So let's say that the 6 vegetables, we're just going to call them A, B, C, D, E, and F, and we can have 2 of them. One part that people get tripped up on is that the combination does not include 2 of the same vegetable. We're only looking for when the vegetables are different. So A and A vegetable would not be one that's valid. So we'd have A with B, A with C, A with D, A with E, and A with F. So we have 5 combinations so far. Now B with A, we already have that here. The order of these vegetables don't matter when they're thrown into the omelet. Which one was thrown first, which one was thrown second. It's essentially the same thing. So we already have B and A. B and B we're not using because we want different vegetables. So we have B, C, B with D, B with E, and B with F. So we have 4 combinations there. You may start to see a pattern here that C, we already have it with A, with B, not with C. So we have C, D, C, E, C, F, plus 3. And yes, you're right that you're just going to keep on adding until you get down there. So we have 5 plus 9, 5 plus 4 plus 3 plus 2 plus 1, 9, 12, 14, 15 possible combinations. The actual formula that you could use on this is that the combinations is n factorial, k factorial, and then n minus k factorial. Factorial refers, well, you'll see. So the n is the total number of options. So we'd have 6 options. And then the number of selections, that's what k is referring to, 6 minus 2 factorial. And then each of these, so 6 factorial means 6 times 5 times 4 times 3 times 2 times 1, divided by 2 factorial would be 2 times 1. And then 4 factorial would be 4 times 3 times 2 times 1. We can cancel out all these. So we have 30 divided by 2, or 15. Now you won't be provided this formula, but basically run through a problem like this visually is going to be probably the fastest way without getting into the nitty-gritty. Another example to build off the previous problem, say that you're the omelet maker, you're the chef, and you're placing the 6 different vegetables in the serving line. How many different ways can you arrange those vegetables? So you'll have 6 places. Let's say that you can actually place the vegetables. And so you have 6 places, 6 vegetables. How many different ways can you arrange the vegetables? So for the first one, well, you have 6 vegetables, so you can place any of them in that first slot. You come to the second slot, well, you've already placed one, so you only have 5 available options, and we'll continue down until you're at the very last one, and you just have to place whatever you have left in that last spot. So then we'll come through, and the way we see how many different arrangements can be made is that we actually multiply all of these through to see what the number of arrangements possibly is. In other words, you may see that this is actually 6 factorial, and we plug that into the calculator, and you end up with 720 different ways you can arrange those 6 vegetables. Now let's say a question said that there's only 4 slots available for the 6 vegetables, then you would just do 6 times 5 times 4 times 3, because that's the number of possible combinations you would not multiply by 2. So basically half of this 720 or 360. Number 9, probability of an event. Probability refers to the likelihood of something happening. In other words, the number of times a specific event occurs divided by the total number of possible events. Let's jump right into some examples. Oftentimes you'll see questions referring to decks of cards or dice for these types of problems because they're easy to use. The first question here, what is the probability of pulling a face card from a deck? So we know face cards referring to kings, queens, jacks, and the like. There are 12 total face cards in a deck of cards. Total deck of cards, there's 52. So we'd simply say the probability of pulling a face card from a deck is 12 out of 52. You could also simplify that to be 3 out of 13. You could also change that over into a percentage of 23%. Another question could ask, what is the probability of rolling 3 dice and getting all 5s? So we know that the probability of getting a 5 with a single dice is 1 out of 6. The fact that it's a 5 doesn't really matter. We just know that there's 6-sided dice and there's only one side that shows 5. So that would be 1 out of 6. To do it 3 times, we would simply multiply each time that we roll that dice and get the final answer of 1 over 216. We're changing that into a percentage. It's going to be something like 0.5% chance of that actually happening. Similarly, a question could ask, what is the probability of rolling 2 dice that sum to 6? So basically it's asking, what is the likelihood that you roll 2 individual dice and they add up to be 6? So of course, anytime that one of the dice rolls 6, the other one has to be more than that. So this is only going to occur a limited number of times, specifically when the first dice rolls a 3 and the second dice also rolls a 3. You could also have the first dice roll a 4, the second one roll a 2. The opposite is going to also be a unique event where the first one rolls a 2 and the second one rolls a 4. It's not the same. We're not going to combine the two where the same number shows up but on different dice. These are unique events, so each one occurs. We also have where 1 and 5 can be rolled on either one. So we have a total number of 5 times that it can happen. And if we're rolling 2 dice, we know that the total number of possible outcomes is just 6 times 6. So 5 out of 36, that's the probability of rolling 2 dice that sum to 6. We could also change that into a percentage if need be. So thank you for watching. Let me know if you have any questions in the comments. I'll be keeping an eye on those. Let me know if this video is helpful by throwing me a like. And finally, if you want to keep updated on my future videos as they come out, make sure you subscribe. After all that, check out these other videos. Welcome back to the channel. Today we're going to be going over the third topic of the GED math module, Basic Algebra. As a reminder, you'll be able to use a calculator on some of these problems and you'll be provided a formula sheet. If you need further studying for any of these individual topics, I'll be linking to other videos for a deeper dive in the description. Most of those will be Khan Academy videos, but there may be a few other channels in there as well. Number 1. Add, subtract, multiply, and factor linear expressions. First off, a linear expression is any algebraic expression that has constants and variables raised to the power of 1, meaning that you're not going to have anything squared to the power of 3, something like that. And when plotted, which we'll be talking about in the next topic video, it'll create a straight line as compared to something that has a U or curves, anything like that. It's a straight line when plotted. So another note, the difference between an equation and expression, just having an equal sign in there, that it's a full equation versus expression. So an equation will look something like y equals 3x plus 1/2, while an expression is not going to have the equal part we're just having, a simple algebraic thing that we can work through. So quickly through each one of these, when adding them, when they have the same variable but different coefficients out front, we can add those together. So that would be 6x. When subtracting, same thing. That will end up being like 1 minus 5, so negative 4x. And then when we expand and we have a multiplication on the outside of a parentheses, we will carry that through. So 6 times 2 is 12y plus 6 times 4 is 24. And finally, when you factor, you're trying to pull it out. So we're working in reverse here. So we could divide everything by 6 here, but then we see that, there's actually 2 and 4 in here. We can divide everything actually by 12. So we can pull the 12 out, and then we have y plus 2. A question could ask you to simplify a combination of these different methods here. So we have the question: simplify 2 times x plus y within parentheses minus y minus 3x within parentheses. So first off, we'll carry through each of these coefficients outside the parentheses. So we have 2x plus 2y, and then this like a negative 1 out here. So then we'll have minus y plus negative times negative 3x. And then we'll combine the terms where possible. So we have 2x plus 3x, 5x plus y, positive 2y minus 1. Number 2, evaluate algebraic expressions. For these problems, you'll simply replace variables with numbers given an expression. Basically what I call the plug and chug. A sample question tells you that a coffee shop sells drinks and food. The income is represented by the expression 3D plus F. That's important, where D is the number of drinks sold and F is the number of food items sold. On their busiest weekend, they sold 1,750 drinks and 900 food items. What was their income? So we simply will plug in the numbers. So 3 times 1750, because that's where the D is, plus 5 times 900. And plug that into our calculator and end up with an income of 9750. Number 3, create algebraic expressions. You'll basically be working in reverse for these types of problems, so let's jump into 2 examples. A coffee shop makes $3 per drink and $5 per food item. You might recognize this. Which expression represents the shop's income? So simply, we know that it makes $3 per drink, we'll call that D, and $5 per food item, we'll call that F, and that's the answer. The nice thing about these types of problems is that they are multiple choice, so you don't actually have to create the expression, you just need to choose the one that represents the description. The second example here, a race car comes out of a turn at 80 miles per hour and gains 5 miles per hour every second afterwards. Which expression represents the car's speed after t seconds? So it comes out of a turn, so starting at 80 miles per hour, and then it gains 5 miles per hour every second afterwards, and the seconds are represented by t, we're told, so it's simply 80 plus 5t. Number 4, add, subtract, multiply, divide, and factor polynomials. First off, a polynomial is any expression with coefficients and variables, and the powers can be greater than 1 as compared to the linear expressions. In fact, a linear expression is just a type of polynomial expression. So some examples here, this is a polynomial expression. The 3, we call that a coefficient. And this goes for anything looking like this in general. The x, we're calling the x the variable. And then we have that raised to the power of 2. So anything that's non-negative power is going to qualify as a polynomial. Other examples here, you can have multiple variables, y plus 5n to the third. Another example of a linear polynomial expression would be x plus 1/2. We've seen those before. Let's run through an example of each. So adding and subtracting, we will follow the same simple rules we have previously, raised to the power of 1, except that we cannot combine terms that are raised to different powers. We'll see that. So 4x plus, it should be a 1 in front of there, basically. So that would be 5x. And then we have x to the power of 2, or squared, minus 3x squared. So basically 1 minus 3, so we'll have minus 2x squared. We cannot combine these because they're raised to different powers. For division, this is a simple one here. There's a chance you could see something more complicated. I'll be referring to a Khan Academy video in the description. So here we could see that we can simply pull out the 6x from up top, divide everything by 6x. So then we end up with 2x minus 5, still divided by 6x. We can cancel those out, and the final answer, 2x minus 5. Multiplication, we'll have to go through and multiply everything through. So the way that looks, we take x times 3x. That ends up being 3x squared. X times 2, so plus 2x. 3x times negative 1y be negative 3xy, and then negative 1y times 2, so minus 2y. Then we can look through, there's no variables with coefficients that we can combine, so that will be our final answer. And then for factoring, this is where you need to get a little bit creative possibly, but basically you're going to look to turn this into that, two expressions multiplied by each other. So basically the first thing you need to do is to find the whole number coefficients. The easiest way here is, okay, what are the factors of 8? We have 8 times 1 and we have 4 times 2 are the possible factors of 8. Like I said, you're going to have a 3x out front and you know an x here, so that when those are multiplied you get 3x cubed or 3x squared. And then you're going to need to figure out by placing in these, and we've got negative numbers, so we know that there's going to be a positive and a negative. Okay, so let's say 3x, let's try this. Let's put a 2 in there and a 4 there. If we tried that, we'd have 3x squared, and then minus 2x plus 12x. Okay, so that's going to end up with a positive 10, so we know that that's not right. And so let's try 3x plus 2 and x minus 4. And that way we'd have plus 2x minus 12x, so that gets us that negative 10, and 2 times negative 4 is negative 8. So this is going to be the correct answer. Number 5, create polynomials from descriptions. Again, you'll be working in reverse for these problems, given a description and you're asked to come up with an expression. Again, multiple choice questions, it's going to make it a little easier because you just have to select the correct one. You'll see 2 types of problems here, real world description, and you'll see descriptions of different shapes and asking you to calculate areas and perimeters. First one here, a rectangle has side lengths x plus 3 and 2y minus 1. Write an expression for the area and perimeter. So the area we know is simply going to be the sides multiplied by each other, x plus 3 times 2y minus 1. And then if we go ahead and multiply these through, and we look and there's no terms we can combine, so either this or this will be our answer for area. Perimeter, on the other hand, is adding up all the side lengths. So it's a rectangle. We know that there's 2 sides represented by x plus 3 and 2 sides represented by 2y minus 1. So we'll do 2 times x plus 3 plus 2 times 2y minus 1. And we could multiply these through and get the final answer. A real world scenario example problem is this. A landscaper charges a flat rate of $70 plus $40 per tree and $20 per flower bed. Write an expression. So simply, we've seen a problem like this before. We start at 70 and then we'll add on $40 for every tree and $20 for every flower bed. Number 6, add, subtract, multiply, and divide rational expressions. A rational expression is basically just a fraction with polynomials in the numerator or denominator. So subtracting or adding, we will need to find a common denominator. To do that, we'll multiply through by 1 in the form of the denominator of the other side. You'll see what I mean. So here we have, we'll move that over to x over x plus 4. That was a mistake, don't worry about that. We're going to multiply that through by 1 or x over x, which is just 1. And then continuing through minus 2 over x multiply that by the denominator of the other side, so x plus 4 over x plus 4. Then we'll multiply those through, so we have x squared. You can see we have common denominators now, so we'll pull everything together. So x squared minus 2x plus 8. All divided by x times x plus 4. If we carry these through, the answer is going to look, it could be a combination of some of these. They may pull out that x there. They may not. Just look for the correct answer depending on what you've worked out. The other types of problems will be multiplications and divisions. The first thing that we want to look for is if we can factor out anything that's going to cancel out. So for the x squared plus 3x minus 10, if we look for common factors of 10, we have 5 and 2, or 10 and 1. So 5 and 2, the difference between those is 3, so more than likely that's going to fall in there somewhere. That would give us x squared plus 5x minus 2x, so plus 3x minus 10, so that's that factored out. Again, that's all over 1. And we're multiplying that x plus 2. I'm just going to put that in parentheses. Then we can pull out at least a 2 from the bottom here. So let's go ahead and do that. And then we can start to look and see what else could be factors. This x squared minus 4 can be factored out. So factoring x squared minus 4, 2 and 2 will equal 4, and if we have a positive and negative, they'll cancel out, resulting in no x factor in there. So this could be x plus 2, x minus, that should be a 2. 2x minus 2x, no x, minus 4, so that's that factored out. Then we can see that some of these are going to cancel out, the x plus 2 and x plus 2. We're multiplying everything here so we can work all the way across. X minus 2 cancels out that, x minus 2, and we're simply left with x plus 5 over 2. Similarly, if you're given a division problem, so if you were asked to divide a problem, the thing to do first here is to change the division to a multiplication and reverse these. That's the quick and easy way to do that. But simply flip the second half, change it over to multiplication, and then work through the problem just as you would a standard multiplication problem. Number 7, write an expression from a written description. You'll be provided with a somewhat technical description of an expression and asked to derive or pull out the expression from that description. A few key terms to know: sum is referring to the addition of two different numbers. The difference is the subtraction of those two different numbers. Times refers to the multiplication of two numbers, and quotient refers to the division of two different numbers. So a problem could look like this. Okay, so it says the quotient of the sum of 4, so we have quotient of the sum of 4 and 2 times a number, and the difference of 6 less than 3 times the same number. All right, so let's start separating these out. So we got the quotient, that's the overall problem. So we know that there's going to be a division in here somewhere. The quotient of the sum, so the addition, so we have sum of 4 and 2 times the number. That's all in one thing. So sum 4 plus 2, and the way it's written, it's just 2 that's being multiplied by that number. We're going to call that number x. And on the bottom of the division is the difference of 6 less than 3 times the same number. Okay, so 6 is going to be less than 3 times. We're going to have to subtract 6, and 3 times the number is 3x minus 6 on the bottom, and that is our final answer. Now again, these are going to be multiple choice questions, so it's going to be a little bit easier to pick out a correct answer as compared to coming up with the expression all by yourself. Number 8. Use linear equations to solve real-world problems. For these problems, you'll need to create an equation from a written description and solve that equation. In particular, you'll be asked questions about fuel efficiency, so I have 2 examples here. The first one says that a car's odometer read 31,774 miles when the tank was filled with 17 gallons of fuel. At 32,483 miles, it ran out of fuel. What is the efficiency of the car in miles per gallon? So we'll simply subtract the 2 odometer readings to see how many miles were traveled in total, divide it by the number of gallons. Simply plug that into your calculator and you will end up with a amount of 41.7 miles per gallon, or 42. The second problem we have here is that a car has a fuel efficiency of 32 miles per gallon at 60 miles per hour, but loses 2% efficiency per 1 mile per hour over 60 miles per hour. What is the mile per gallon at 72 miles per hour? So the expression, it has a fuel efficiency of 32 to start off with, and then we're losing, so subtract 2% efficiency. So if we look at that in a decimal, that's 0.02 per 1 mile per hour over 60 miles per hour. What is the mile per gallon at 72? So this is the speed right there that we came up with. So we'll have 32 minus 0.02 and then 72 minus 60. So we're needing the difference between 72 and 60 to achieve our desired result, and we plug that through the calculator and end up with 24.3 miles per gallon. Number 9, solve a system of 2 linear equations. For these problems, you'll either be given 2 linear equations or given the description of 2 linear equations, and you'll have to come up with those. But there are 2 different ways to solve these types of problems. The first one, we're going to call it system addition, but basically we're going to try to find like coefficients so that when we add the 2 together, we'll have some canceling out of variables. So in this case, first off, let's move over that minus 4. So then that's what we're working with. And let's try to isolate the x variable. To do that, we'll have to multiply the bottom side here by 2 so that when we add them together, we'll have 2y minus 2y, they cancel out. For here, keep the top the same. And on the bottom, if we multiplied everything by 2, we'd have 2x minus 2y equals negative 8. Now we'll simply add the 2 equations together, so we'd have 5x, these cancel out, and that will equal, we add those together, negative 3. We end up with a final answer of x equals negative 3/5. The other way to solve these types of problems is through substitution. This is actually, I prefer going this route. Basically, you'll isolate a variable in one of the 2 equations and then plug that into the other equation. So what that looks like is, let's isolate the y variable of the bottom equation here. So if we added y to each side, we'd have y equals x plus 4, and then we'll plug in x plus 4 for the y in the top equation. So we have 3x plus 2, x plus 4 equals 5, and then we'll work through that. So we have 3x plus 2x, so we'll have 5x plus 8 equals 5. Subtract 8 from each side, we have 5 equals negative 3, and then divide, we have x equals 3/5. Same answer on each side. If you need to find the y, then you'll simply plug in negative 3/5 for x in either of the equations and you'll find y. Number 10, solve inequalities and graph those answers on a number line. For these problems, you may be given a written description and asked to solve it. You may be given a written description, asked to solve it, and plotted on a number line, or you may just be given an inequality and asked to graph it on a number line. So we're going to do all 3 here. So Isabella saved $15,000 and bought a $12,700 car. The insurance is $600 per year. How many full years will the remaining money cover? We know that 600 times number of years has to be less than or equal to the remaining funds, which is 15,000 minus 12,700, we will go ahead and carry that through where y has to be less than or equal to 3.8 years. And if we take that to be a full year, then we know that y has to equal 3 years. We can even call that less than or equal to 3 year. So on a number line, if we have 0, 1, 2, 3, 4, -1, -2, -3, -4. On a number line, y being less than or equal to 3 years, it's going to look like this. We'll have a closed dot and then the line extending backwards. And that is y is less than or equal to 3 years. Anytime that you have an open circle, that means it's less than or greater than, but not equal to. Anytime you have a filled circle, that's going to mean less than or equal to or greater than and equal to. A little bit of clarification for number lines through examples here. So a closed dot extending forward, that's y greater than or equal to 1. With an open dot, that would switch to y being greater than 1, but not equal to. If we have a closed dot and an open dot here, showing that x is greater than -1, but not equal to, and then less than or equal to 1. And then if we have two separated going in opposite directions, we could write it like x being greater than or equal to 0 or x being less than -1. Number 11, quadratic equations with one variable. A quadratic equation is any equation that can be put into the form of ax squared plus bx plus c equals 0. There's 3 different ways to solve these problems, which I'll run through here. So the overall question could ask you to solve 4x squared minus x equals 5. Well, first off, we'll move it into the quadratic so we can pull out the a, b, and c. So that would look like 4x squared minus x, move over the 5, so it's minus 5 equals 0. The a term is going to be the 4b term will be -1, and c term will be -5. First way to solve this problem is simply using the formula, which can look a little bit intimidating, but simply you'll plug in all of the numbers and follow through to solve. So let's do that. For -b, we'll have negative times -1, so that ends up being +1 times the square root of b squared, so -1 squared, minus 4 times a is 4 times c is -5 divided by 2 times 4. If we work all that out, we'll end up having, we forgot the plus or minus right there. So we'll have 1 plus or minus the square root of, that'll be 81, which is nice because that's the square root of 81 is 9. Nice even number, divided by 8. So then we'll have 1 plus 9 divided by 8 and 1 minus 9 divided by 8. So 2 answers here, which is what you'll expect for quadratic equations. You'll have x equaling 1 plus 9 divided by 8, so 10 divided by 8, or 5/4. And then you'll also have 1 minus 9, so -8 divided by 8, or -1, are your 2 answers. That's through solving it via the quadratic formula. The second way to solve these are to factor 4x. If we do -5, multiply that through, and then what, 4, because it's a difference of 5 and 1, so that's seeming promising. Let's try -5, because I don't want to multiply that by 4. That gets too big of a number. And then we know that x has to be there. And then we're going to be adding on, if we have 1, we end up with 4x squared plus 4x minus 5x, so that's -1x, that's right. And then -5 times 1, -5, so that's correct. Then we'll split these out because basically we know that this is equal to 0. So one of these 2 terms is going to have to be 0 to multiply by the other one to end up with a final answer of 0. So we have 4x minus 5 could equal 0, or x plus 1 could equal 0. Follow those through. We would have x equals, move over the 5 divided by 4, x equals 5/4, or x equals -1 which is the same answers we got up here. Finally, the third way to solve these problems is to plug and chug the given answers into the formula that you're given. So basically, since these are multiple choice problems, you'll be given a set of possible answers, and you can run through, plug each one of those answers into the equation and see which ones solve the equation correctly, where plugging it in makes it equal to 0. That's the tried and true way of doing it. If you're getting screwed up by the formula or by trying to factor, then this is going to be your go-to quickest method, is just to try out all the numbers, see which one works. So again, thank you for watching. I'll be working on the fourth topic of the math section coming up here soon. Let me know if this was helpful by throwing me a like. Let me know if you have any questions about a certain topic in the comments. And finally, to keep up on my future videos on the math section and other GED modules, subscribe. Finally, after all that, check out my other videos. Welcome back. Today we'll be covering the fourth topic you need to know to pass your math GED, graphs and functions. Additional study resources for each individual section will be linked in the description. I'm not overlaying background music on this video, so let me know in the comments if you prefer not having the music. All right, let's get started. Number 1, locate points and graph equations. Let's plot 3 points. We have the x-axis and y-axis, and when looking at points, the x variable will come first, followed by the y variable. So when we have -4, 1, we'll move back -4 on the x-axis and up 1 on the y-axis. So that would be j right there. When we have 0, 3, we'll not move anywhere off the x-axis, so we stay in the center and go up 3 spots. So it'd be 0, 3, or k right there. For -2, +3, we'll move back 2 here and then up 3 right there. On the GED, the problem will be in reverse of what we just did, where it'll show you the graph and ask you which points are correct in the multiple choice possible answers. For graphing equations, we'll remember that lines have an equation that looks like y equals mx plus b, where m represents the slope, and slope is going to be the rise over the run, and b represents the y-intercept. So let's say that the question asks you to determine the equation of the line shown here. We can start by knowing that the equation will start with y equals, and then let's find the y-intercept, that is -2, and the slope being the rise over the run, what comes up 1 and over 2. Okay, so we know that it is going to be 1/2. It is running from in this direction, meaning that it's going to be negative. If it was running in this direction at all, it would be positive slope. But since we're going from this quadrant to this quadrant, it's going to be negative. And then x, and it is a -2 y-intercept. Number 2, slope of a line from a graph, equation, and table. To determine the slope of a line from a graph, it is the rise over the run, which we covered in skill number 1. So jump back to that if you want to review. Determining the slope of a line from an equation, you'll need to isolate the y variable. So as an example, it asks you to determine the slope in the equation x plus 4y equals 8. So first we will move over the x to the other side, so then we will have 4y equals -x plus 8, and then we will divide everything by 4 to isolate the y. So we'll have 4y equals -1/4 x plus 8 divided by 4 is 2. And then the slope, again, it is that -1/4, so the answer would be -1/4. For determining the slope of a line from a table, You will select 2 appropriate points from that table and then determine the slope of the line. And if you want to see how to do that, jump ahead to skill number 6, where we cover determining the slope from 2 points. Number 3, proportional relationships for equations and graphs. A proportional relationship, all you need to know is that it's some fancy words to describe the slope. So a question could be, Cody sells snacks. The equation P equals 3S can be used to find profit P for Cody after selling S snacks. What does 3 represent in the equation? Well, 3 is the proportional relationship between Cody's profit and the number of snacks that he sells. So what does 3 represent in the equation? Well, let's say he were to sell 10 snacks, and that would end up being $30. Well, it should be obvious that 3 is the price per snack in that proportional relationship. Number 4, features of graphs and tables. With the knowledge of skills number 1 through 3 combined, we're going to be interpreting graphs or data points from tables that would be overlaid on a graph. So I am going to put up a sample question on the screen and read it out loud. So it says, Kristen walks up 6 flights of stairs to her office each morning as part of her exercise routine. She walks the first 3 steps, rests for 30 seconds, walks the next 2 flights at the same rate as she walked the first 3 flights, rests again for 30 seconds, then walks the last flight of stairs at the same rate. Which graph represents Kristen walking up the stairs? So let's go ahead and graph this. So she walks up 3 flights of stairs and then rests for 30 seconds. So we'll go ahead, she starts at ground level, walks up, and gets to the 3rd flight. So the slope of this line right here would represent how fast she's moving, or her pace. So she gets up to the 3rd flight and then rests for 30 seconds. Then we're told that she walks the next 2 flights of stairs before resting again, and she's walking at the same pace. So the slope of the following line is going to be the same as the initial line. So we'll connect, go up 2 flights, and then stop. And those slopes are the same. Then it says she rests again for 30 seconds. So she's not moving up any flights of stairs, but time is passing. And it's 30 seconds again, so it should be the same length as her previous rest. Then we're told that she walks up the final flight at the same pace or with the same slope as her previous walking. And that would be your answer. Number 5, determine the equation of a line when given the slope and a point on the line. A question could ask, find the equation of the line with a slope of 3 and passes through the point 1, 2. You'll need to find B, the y-intercept, or in other words, isolate B. We'll go ahead and put down the 2 for y and 1 for x and 3 for m. Now that we have those in place, we'll simply isolate B. We know now that the y-intercept B is -1. Then we simply will put everything together here. We know that the slope is 3x plus -1. That'll be your final answer. Number 6, equation of a line from 2 points. To solve these problems, you'll need to know how to solve a system of equations, which we've covered in a previous video. A question could ask, what is the equation of the line that passes through the points -3, -2, and 1, 6? First, we'll need to determine the slope, and we'll do that by using a system of equations. From the point -3, -2, we have -2 equals m times -3 plus b. We're using the y equals mx plus b form. And for the point 1, 6, we have 6 equals m times 1 plus b. To isolate the m here, we will subtract the lower equation from the upper equation, because that will be b minus b. Those will cancel out. We have negative 2 minus 6, which will be negative 8. And then we have negative 3m minus 1m, so negative 4m. Negative 8 divided by negative 4 is 2. Then we will find the y-intercept. Again, we can use point negative 3, negative 2 in the slope formula. So negative 2 equals, we determine the slope to be 2 times negative 3 plus b. Now we only have b to work with, and that works out to be 4. Putting all of this together then, we have y equals slope of 2, so 2x plus 4. And that would be your answer. Number 7, use the slope of a line to solve problems. In particular, you'll need to determine if lines are parallel or perpendicular. Parallel meaning that they run side by side and have the same slope. Perpendicular meaning that they are opposite in slope and when graphed they would meet at a 90-degree angle. So a question could ask, what is the slope of a line that is perpendicular to 5x minus 2y equals 1? First, we will get into the standard slope form, and it works out to be y equals 5 halves x minus 1 half. If the question were to ask what is the slope of a line that is parallel, well, then it would be the same. Parallel would be 5 halves. Perpendicular, on the other hand, it will be the opposite slope. So what you're going to do is you're going to flip the 5 and 2 and then reverse the sign out front. So that would end up being negative 2/5 is the answer to this problem. Number 8, compare functions shown in different ways. Those different ways could be through tables, graphs, equations, or written descriptions, but you'll need to convert both of the functions into one of these, most likely into an equation. So a question could ask, 2 shops sell shirts. The first shop charges $24 per shirt plus $8 shipping. The other shop uses the equation C equals 22n plus 12, where C is equal to the total cost and n is the number of shirts. And it asks, what is the difference in cost if ordering 10 shirts? We will convert the first shop's charges into an equation similar to the second shop's. I will call that C1 is equal to, well, they have $24 per shirt. If we follow the other equation, we will call the number of shirts n, and then we have $8 for shipping added on. We are already given the equation for the second shop, which I will call C2, that is 22n plus 12. If ordering 10 shirts, we will plug in 10 for the n. So for C1, we will have 24 times 10, so 240 plus 8, $248 for the first shop. For the second shop, we will have 22 times 10, so 220 plus 12, or 232. Then we will subtract 248 from 232 to get $16 being the final answer of the difference in cost. Number 9, functions in tables and graphs. You'll need to be able to recognize a function in a table or a graph by determining whether or not there is only one output for every input. For example, let's say that a function represents the equation for a line y equals 3x plus 2. So the function only has one input, x. And for every input, there should only be one output. In other words, if we plugged in a certain number x, we couldn't be getting multiple y's out of that equation. So a question could ask, which represents a function? So we are given 2 tables with different points, and I've gone ahead and plotted those points to see what it looks like. The first table has the points 0, -4, 0, 4, 2, -3, and 2, 3. As you can see, for a single input of x, there are multiple outputs y. So we can tell already that this is not a valid function. If graphed, we can see that it actually most likely curves around, but specifically these points here, which are given. If we run a vertical line, we're going to be seeing that there are 2 outputs for every input x. On the other hand, this table has the points -5, -4, -4, -4, -3, -2, 0, -1. It doesn't matter if you get the same output for different inputs. As you can see in this case, when putting in -5 or -4, then the resulting y is they are both -4, but that does not make this function invalid. It's only when there's multiple outputs for a single input. When graphed, this would look somewhat like this, and if you try passing a vertical line through any point of this function, you are only going to end up with a single y value. So your answer would be this one. Number 10, evaluate functions. These are simply plug and chug problems. I've written the same question 2 slightly different ways. Let's go ahead and solve it. It asks, what is the value of the function x squared minus 3x when x equals -8? So we'll write in f, the function with an input of -8 equals -8 squared minus 3 times -8. Well, -8 squared is 64. 3 times -8 is -24. And we have that's subtracted, so it'll be plus 24. The answer is 88. Simple as that. And that wraps it up. Let me know what questions you have in the comments, and stay tuned for videos on the other GED modules.